Okay, good afternoon, everyone. It's Dr. Sam Jensen here. Today we're going to talk about a strong base weak acid titration lab. Okay, so we're going to use a simulator. So usually this is something we would do in class, but in this case we are going to use the simulator that we have. So the normal document, so let's take a look at the normal lab handout. All right, so this is the lab handout that'll go with this lab normally. So again, this is for a acetic acid titration. Okay, so but everything in this handout is still pertinent to this particular experiment that we're going to do via the simulator. Okay, so now in 111 we would have done at least some version of a strong acid, strong base titration, where our equivalence point we know will come out at a pH 7 because the strong acid, strong base neutralize each other. But since we're going to deal with a weak acid, we have the production of buffers, and so it shifts our equivalence point, because over here we have the production of basic ion left over, so that pushes our pH up a little bit, and we're going to have a buffer region that we have to work from. And so the goal for the simulator is to determine not just the identity of the unknown, but also its concentration. So in this particular lab, when we would do this in person, our goal here was to determine the pKa and the concentration. So in this particular one, we already know that we were working with acetic acid. Okay, so everything was set up that you're working with acetic acid as a weak acid, and we were going to try and find the equivalence point and then find the concentration of the acetic acid. Okay, so this particular titration is different from the one we would have done in 111, because in this particular titration we would be using a pH indicator to create our pH curve rather than using an indicator. So if we're working with a weak acid and we're not sure, particularly in the experiment where from the simulator, if we don't know what the acid is, then it would be hard to particularly choose an individual indicator if we're not entirely sure where the endpoint is going to be. Okay, because from the simulator there are a variety of different unknowns. Right. So let's switch back to the handout that is going to go with this. Okay, so this is just a slight update to the procedure based on the simulator. So here's the link for the simulator, which we'll get over to in a second. So essentially the simulator gives us a set of particular unknowns where we don't know exactly what the acid is, and so we're going to determine that via the pKa. Okay, so most of this is going to be fairly simplistic, so really you're going to need the unknown acid. There's a burette that we can pull out. We need an empty flask and some sodium hydroxide. Okay, and so really the bulk of this is going to come down to determining how do we go about doing the experiment. Okay, so let's actually switch over to the simulator here. And you can see what I'm talking about. All right, so I pre-positioned a few things here. All right, so you have 1 molar sodium hydroxide. From the stockroom here, you have a variety of strong bases to pick from. You can pick different concentrations of the sodium hydroxide. Again, if you don't know what concentration you're working from, it's probably best to start with the 1 molar sodium hydroxide for this. Okay, I took the unknown acid, which is located over here, and from the glassware we could get under other the burette and an empty Erlenmeyer flask. And so I transferred the unknown acid. So essentially from the flask, I would have transferred from my unknown acid, just dragging it over till a little green thing shows up, and then transferring 25 milliliters, and then disconnecting. Okay, so essentially I have 2 samples here. You probably want to do a couple of samples of the unknown. Particularly I found that when doing this, there's probably a few trials where you got to kind of go back and check check your data. So the first time, since we don't really know what the unknown acid is, we're not sure what its concentration is truly kind of an unknown. The first trial is really kind of a throwaway, okay? And so what you'll notice here, all right, so let me disconnect this again. All right, if you click on the acid itself, over here gives you the pH of the acid. So this is the pH before we've added anything to it, okay? So now if we put this on here, and I did this for the first trial, we're just adding 1 milliliter at a time to see what happens. And so when I add 1 milliliter, okay, so automatically here you'll see the pH now jumped to 2.47. And so what I would do is on a sheet of paper or an Excel sheet, record down your pHs with each subsequent volume aliquot that you put in there. So here is now 2 milliliters. Okay, so every subsequent one is just going to be an additional 1 milliliter. So I'm at 2 milliliters now. And then again at 3, and you'll collect another pH, and at 4. And so you just keep going through this, and with every time, you'll be collecting X and Y data for your Excel sheet. So with each new volume, and then see, then we got a jump. Okay, that would have been that big jump. So we're past the equivalence point, but I'm doing it in 1 milliliter aliquots. So that's probably not super accurate. And so again, the end point here, and the point of this titration curve, since we don't have an indicator, you want to go past this a little bit. So in the write-up, it says about 2.55 is where you want to go, but you probably want to go at least a few milliliters past the end point. Okay, so here I've up to 2.87, and then one last aliquot here, and now I've reached pH 13. Okay, and so that would give you a very gross graph done by 1 milliliter. So it's not going to give you a lot of great data at 1 milliliter. Okay, but again, with the different unknowns, it's hard to say what the outcome is going to be. Again, you have a whole bunch of different possibilities here, and I'm not entirely sure how many variations there are within the simulator. I found at least 2 or 3 variations within the simulator so far. So it's not to say that if you keep going through this, that it's not going to keep getting other unknowns, right? So what I would do is once you kind of get a rough idea, is I would take a second trial, and in this case, some of the titrations, they only took like 2 or 3 milliliters. So if it's only 2 or 3 milliliters, then you probably want to bring it down to a much smaller increment. So maybe doing it by either 0.5 or 0.25, or even as little as 0.1 aliquots. Okay, so again, here you want to look at what is your initial pH before you've added anything. And then if we're going to go in 0.1 milliliter increments, okay, and then at 0.1, my pH has gone up a little bit. So this one's going to generate a lot more data. Obviously, if we're doing it in 0.1 increments, you're going to keep adding and keep recording pHs until you hit your endpoint. And you're going to generate a lot more data from this. Okay, so obviously for every 1 milliliter before, I'm now generating 10 more data points for each trial. Okay, so we'd keep going. And again, this is not super difficult to do, especially once you have the simulator. It's really what I would do is probably do this in Excel as well, and then just type over your pHs, and then that way you do it once. And so as you kind of scroll through and you do enough trials, okay, and you'll keep adding, and then see there was our jump, right? And so as we go through and do this at a smaller amount, we get a larger set of data, okay? And so you probably want to have at least 2 trials with this. Now, I found that probably I might do a second or a third one just for something like when you have your graph, when you're trying to define the pKa, and if we're doing it visually from the graph based on our plot, what we may want to do is validate the actual pH. So let's say, for instance, you determine that your halfway to your equivalence point is at, let's say, 3 milliliters. And from the graph, it looks like the pH is like 1.5, but we want to double check that. And so what we would do here is then 25 milliliters is then you could come back over here and rerun the experiment and just say, okay, what is the pH at, if my equivalence point was at 4 and I'm saying halfway is at 2 milliliters, so what is the pH at 2 milliliters? And then it would give you the pH right there at 2 milliliters rather than having to estimate it based on what your graph looks like. Okay, so you might do a third one just to check what is the actual pH at that volume. Okay. All right, so like I said, the simulator is relatively straightforward. It takes just a little bit of practice to maneuver the various solutions around and adding the various components. So what I'm going to do here then is take you back over to an Excel sheet and show you what this will look like when you're putting this together. Okay. All right. So this is a similar data trial. So here I did by half milliliter increments. Okay, so I can zoom in here. All right, so it only took up to 4 milliliters for this first trial, and I did it in half milliliter increments. And so from this, I could generate a very crude graph, right? So here is where I estimated my equivalence point to be at about maybe about 2.75 milliliters. And then you could go back here at 1.3 and then estimate the pH at that point for your half equivalence point. Right? So again, this is not a real great estimation because it's very the 0.5 milliliter difference here between the 2.5 and the 3, it gives a huge jump. And so what I did then is I went back and I redid the graph at 0.1 increments. And say with 0.1 increments, you collect a lot more data. And so you get a much smoother curve. So I get a much smoother curve that kind of leads all the way up to the end. And so from here, I can better narrow down what my endpoint is. So here, it's looking like it's just a little bit past the 2.75, whereas over here it was a little bit before 2.75. So you can see with some slightly better data or with more data points, or the data points are more granular, it gives you a little bit more precise value. And then I actually took this again back and I did within this region, I actually took it up even more. So you can see right here in this region here, I went up by 0.01. So I took another 10 data points and then created another graph where my data is even finer along here. And so from here, I get down to where I think my actual equivalence point is and my half equivalence point. And so here's where I would go back to the simulator and maybe rerun that sample and see what is the pH at 1.42. So this is half of the equivalence point. So if my equivalence point is 2.84, half of that is 1.42. So I'm about right here. And so you could estimate, right? You could estimate what the value is, but you could also then we want to know what is the pH at that value. I don't think I didn't type that in right, but I think it's like the 5.01. All right, so my pH at 1.42, okay, is, you could estimate it at 5, or you could go back to the simulator and actually type in and deliver 1.42 milliliters to the unknown and see what the pH is, which then gives you the pKa and subsequently the identity of the unknown, right? Calculating the concentration is based on where is the endpoint. So this is just like any other titration we've done before. So what is the molarity of your base that you used? What is the volume of the base? So at this point here, the volume times the molarity would tell you the moles of your base delivered, and the moles of the base equal the moles of the acid. And so then you can roughly calculate what your concentration is of your weak acid unknown. Okay, so this is a weak acid, strong base titration. The simulator data is given, the raw handout for how we did do the experiment is given, and the extra simulator method alterations are also given as well. So it's really just a matter of going through and playing with the simulator, trying out to see what you get. And the simulator will give you can check your answer with the simulator. It'll ask you what is the unknown, what is the concentration, and so if you don't get it right, it will eventually give you the right answer once you do it enough times. Okay. All right, that's it for this video, and I will be back with some more calculations for acid base in the next one.